So this week I was inspired a little bit by our reading. I really wanted to play around with the Scotch data set, but since we went over it in the reading, I decided I was going to play around with the wine data set instead. The wine data set is basically three classes with 12 attributes or dimensions describing them. So it's a classification problem. Overall, I felt like Knime was really easy to use after a little bit of a learning curve. I'm just going to take you through what I did. It was very simple. And I ended up playing around with some clustering as well, which I'll show you in a second. Basically, we read the file, we partition it into a training and test set. The training set is 66% of the records, and the test set is 33%. We assigned a color to the class so that we can visualize it simply, and so we can see a scatter plot, for instance. And so we've got three classes divided by into three different colors, and we can actually plot some of the different variables against each other. So here we have flavonoids versus on the X versus alcohol percentage on the Y. And you can see they kind of clump together a little bit, but let's see if we can get the classifiers to and correctly classify the wines into one of the three types. So then we put the decision tree learner on the test set following this flow up here, and we can view the tree. Basically, it breaks it down. There are a total of 117 instances in the training set, and the first divide is on color intensity, and that creates a pure class prediction of for the class 2. And one that's mixed. And then flavonoids is the next break, which gets a pure sample for blue. And then lastly, proline, which I'm not really sure what that is, I'll have to look it up, when used, splits it further into pure classes for class 2 and class 3, the final split. So we have actually 4 pure predictions, relatively simple. We then use a decision tree predictor to take the instances from the test set and then predict what they're going to be based on the decision tree. And we view the score and see how we did, view the confusion matrix, and basically we see that we've correctly classified 56 versus 5 wrong classifications in the test set. With an accuracy rating of about 91.8. Cool. Well then, one problem I had is I thought that this, it's possible that color intensity is kind of subjective. Probably isn't, based on the fact that it's a decimal point, but let's pretend that it might be subjective. So I decided to actually filter that column out and see how we did with taking how much of a drop there was when we took out that largest predictor. We again partitioned it, did the color manager, and we can explore that, but we're not going to again. We learned a model, we then tested that model, and we can then see how we did. In this case, when we remove the biggest predictor, there's still a pretty good split. We can still create a tree that correctly classifies 86.8% of the total in the test set. Now, so I did that. Then I thought, let's play around with some clustering because I haven't really done that yet. So sidetrack, let's turn it into an unsupervised learning problem rather than a supervised one. And I wanted to see play around with k-means. So k-means takes the number, basically tries to find a center point for a group and classify everything as closest to that group. And in this case, I used all of the possible numeric values, and I decided I wanted 3 clusters, so I wanted to basically see if I could clump them up into their classes. Created a color manager to color everything and make sure that we see that the classes are visible, and we can actually look at these. And when we look at the predicted cluster versus the class, this is what we kind of get. Basically, cluster 1 ended up predicting getting almost all of those, and that's just like the decision tree. Basically, that's probably all because of the color, or sorry, the color intensity. But then we have the first cluster, which most strongly correlates with the So this cluster most strongly correlates with this class, and this cluster more strongly correlates with this class, but class number 1 is actually split pretty badly. So this wasn't actually really that good. I went ahead and did an evaluation of it too, and here we see that we incorrectly classify quite a few. This isn't working exactly right because of the way I have it built, but basically you would expect some of these numbers to come through correctly, and they don't. So, and then I finally played around with dbScan. dbScan is a density model. The hardest thing I had about that was that figuring out what the epsilon, what the distance is to create the correct number of clusters that I wanted. And what I ended up getting was actually some noise and a big bunch of clusters around here. And the clustering thing didn't do very well in terms of predicting. But that's just not surprising because, I didn't have any... The aim was not to predict, it was just to see where the clusters are. However, these clusters, I think, could be used later on as evidence for the decision tree.